Let us have a look at the system design question. We need to design a notification service at scale. So first, what are the requirements? We need to support multi-channels. We need to support push notification, SMS, emails, and in-app notifications. We need different notification types. We need real-time notifications, scheduled notification, batch notifications, transactional notifications. We also need to store the user preferences about the channel they prefer, the do not disturb settings, the frequency caps, and the custom routing rules. We also have the management features, notification templates, A/B testing capabilities, and delivery tracking and analytics, as well as rate limiting. We also have some non-functional requirements. On scalability, we need to be able to handle tens of millions of daily active users. We need to handle 1 million notifications per minute. We also need to have reliability, 99.99% availability, guaranteed delivery with retries, and latency of less than 100 milliseconds for real-time notifications. We also need durability, no data loss, at least once delivery guarantee, and extensibility, easy to add new notification channels. So we're going to start with a high-level architecture. First, we have our client applications, our mobile apps, our web frontend, and we have our API gateway layer for request validation and authentication, rate limiting, and load balancing. We have the notification service to process the request, to check the user preferences. We have the message queue, that's Kafka, and we have our workers for mobile, SMS, emails. Now let's have a look in more detail at each component. The API gateway ensures authentication by validating the API keys and JWT tokens. It implements rate limiting per user and per application. Then we have the notification service that's going to do the core processing. We have the Kafka message queue that provides different topics. We have the worker service, the push notification workers, the email workers, and the SMS worker. They integrate with multiple providers. They cost optimize, they handle country-specific regulations. Then we have our data stores. We have our primary databases. We have our user preference databases. We have our Redis to store the cache. We have it could be a PostgreSQL for persistent user preferences. Then we have our templates DB that could be, for example, in Postgres as well. We have our delivery tracking DB. It could be Cassandra for write-heavy operation. And we have our supporting services as well. We have a scheduler service, we have an analytics service, we have the template service, and we also have some key design considerations that we need to take into account. We need to implement delivery guarantees, at least once deliveries. We need a retry mechanism, could be an exponential backoff. For example, we need a dead letter queue to store permanently failed notifications. We need a scalability strategy. We can do horizontal scaling, sharding, caching, and connection pooling. We need to think about reliability patterns in our code. We need to implement rate limiting to limit the spam from some users. There are also some advanced features that we need to take into account. We need to personalize our engine to enable user segmentation. We need to think about A/B testing frameworks, multi-region deployments, and also monitoring and alerting. The key metrics are going to be the throughput of notifications per second, the latency, the error rates, the delivery rates, and the queue depth. So for our alerting, we have to watch out for the error rate spikes, the latency increases, and the queue buildup. So overall, the finished product should have an estimate capability of handling 10 million daily active users. The notification per day per user should be, let's say, on average 10. So daily 100 million notifications. The storage requirements would be 100 million notifications per day times 1 kilobit, so that's 100 gigabytes per day. We keep it for 90 days, that's going to be 9 terabytes. And we have an overhead of indexes, should be about around 15 terabytes. So we need to also think about the peaks that can happen. We could, let's say, have peaks of 350,000 notifications per minute. So we need to factor that as well. We need to handle our failure scenarios and mitigations. We need to have strategies if third-party provider fail. We can mitigate it by having multiple providers. We can fall back to another system as well. What happens if we have a database failure? We can have multi-location deployments with replicas. We can sell from cache. We can implement graceful degradation strategies. What if the message queue fails? We're going to have a cluster, and we're going to have local buffering with disk persistence. Those are strategies we're going to implement to mitigate those scenarios. What happens if we have high load scenarios? We're going to do auto scaling, request throttling, and we're going to prioritize critical notifications. So some other things to consider for the implementation would be what is the technology stack that we're going to employ. A suggestion could be to implement a gRPC or REST API with Go or Python, message queue with Kafka. The databases could be Postgres, Cassandra, and Redis for the cache. The workers could be in Go or Java for performance critical channels. The monitoring could be done with, for example, Grafana or the Elk stack. You could deploy on Kubernetes. Yeah, so I think that's about it for the stack and the implementation. So now let's move on to the trade-offs and alternatives. So we need to take into account that we could trade consistency for availability. We could favor availability with eventual consistency. For example, we need to trade off also the delivery speed and the reliability. Most notifications can tolerate slight delays, but not complete failures. We need to keep that in mind. We can also think about the architecture that we choose, and I think we should go towards an event-driven architecture. That would be, in my opinion, the best choice for this scenario. So in summary, I think we provided an architecture that could provide a scalable, reliable notification service that can handle millions of notifications per minute. I think that system could balance performance, reliability, and extensibility, and also provide room for advanced features like personalization and